In the previous video, we went over some basic motivation behind why we might want to introduce interaction into our visualizations. In the next two videos, what we're going to do is we're going to process some of the common methods that we have for interacting with data visualization. These modules will include both an overview of some common techniques that fall into each of these different categories of interaction, as well as an Altair notebook that you can follow along either simultaneously with the video or after each video to implement hands-on some of the practices and principles that we'll be talking about. So as we mentioned at the end of the last video, we're going to be focusing on interaction in terms of these 7 common categories or common types of interactions. And today's video is going to focus on the first 3 of these, which are selection, or indicating that we're interested in something, exploration, asking our visualization to show me other data, and abstraction or elaboration, showing more or less detail about what's going on in our data. As a reminder, in addition to just walking through examples of these techniques, there is an Altair notebook that accompanies this video that you can either pause after we talk about each of these interaction types, or watch the whole video and then revisit and review the different interaction types as part of your hands-on implementation. Whatever strategy works best for you, feel free to have at it. So I want to start by talking about this idea of selection. When I'm selecting something, I'm essentially telling the visualization that I'm interested in a specific subset of my data. And this subset is represented by the set of marks that I've chosen to select. We have a couple of strategies that we can use to really try and make the selected data pop out and really make it easy for users to quickly find the information that they've selected, whether it be through mousing over, through lasso selection, through using a text box, whatever kinds of input mechanisms make the most sense for your design. So the most common of these techniques is what we call highlighting. So if I have a scatter plot with a whole bunch of blue points, and maybe I'm using some sort of blue color scheme to encode my data, I can highlight values by doing something like making them red, making them brighter, more salient. Here you can see our eye is immediately drawn to these red points. And if you skip forward to the module on perception, you'll see a little bit more about what we mean when we talk about this idea of making things pop out. But for right now, we can just focus on the fact that if we want to select something, one way the visualization can show us that data we're interested in is just to make it brighter. Another way of making data more salient and making it stand out better once we select it is actually low lighting. So the basic idea in low lighting is we're going to take all the data that we don't care about and we're going to make it less salient. We're not going to change the data we've selected at all. So for example, in the scatter plot we see here, we're interested in this class of green points. So we can leave them fully opaque and make the rest of the data that we don't care as much about partially transparent. This makes it really easy to quickly find those core green points that we care about. And we can take this idea to the extreme by using something like filtering. So when we filter, we actually totally remove the data that is not selected. So you can think about this as that kind of zoom and filter details on demand metaphor we talked about in the last video, the visualization mantra. This is taking that same idea to heart, that we want to just go ahead and remove the data that we haven't selected. And that way we can really focus on those things that we care about. So it's one thing to try to find all the related data values that we're interested in. It's another thing to try and find something new. Oftentimes when we're using a visualization, we'll start off by trying to answer one question. Then once we've answered that question, we might choose to answer different questions or additional questions that arose as a result of answering our first question. And so interaction can help us be nimble in terms of being able to address multiple questions, multiple workflows, and trace knowledge across different ways of looking at our data. One of the simplest ways that we can do this is through something called panning. So the basic idea behind panning is that we're physically moving our viewport around. So what we see here is 2 different visualizations that will show you different ideas behind panning. On the left, we have the scatter plot here, which you'll recognize from our Altair notebook. And we can see that if we click and drag around the visualization, we can examine different parts of the data in more detail. We're essentially isolating and looking in at different regions, different value ranges on our data. Once we're dealing with other kinds of structures, for example, this 3D molecule that we see here on the right, We can use a lot of the same click and drag metaphor, but in this case, since we're working with a 3D object, we're going to go ahead and click and drag, and we're rotating that object around different axes in 3D space to try to see other elements of the molecule that we might not be able to see. For example, we can't see anything that is hidden on the back of the molecule, so we can rotate the molecule all the way around to see and find that information that's hidden on the back. So panning is a pretty simple, straightforward idea. It's typically implemented using either arrow keys, click and drag, those kinds of basic ideas. But panning, as we see in cinematography and photography, is also often accompanied by another idea called zooming. So when we're zooming, we're essentially abstracting or elaborating the data that we see. We can zoom in to see more detail about the data we care about, or we can zoom out to see less detail. And a couple different kinds of zoom that you might encounter occur in visualizations. The simplest, the one that we're probably thinking about when I say the word zoom, is what is called geometric zooming. With geometric zooming, all we're doing is we're just moving the camera closer to a specific point. So I can see in my scatter plot here, I can use the mouse wheel, or you'll often see the Control plus or Command plus be the keyboard shortcut for this. We can zoom in and see specific regions in more detail. We can blow apart clusters and kind of examine what are the specific relationships between data points in those clusters, look in on dense areas and give them more space, such that what we're essentially doing is allowing ourselves to see the finer grain differences in our data. So geometric zooming is a fairly powerful tool, but you'll recall when we deal with data, we're often dealing with so much data that we have to lump it together. And when we lump it together, this is a process known as aggregation. For example, if I am looking at my data in terms of the average happiness score across different countries, I might go ahead and look at average scores across regions. I have lots and lots of countries in my data set. Maybe I can't necessarily make sense of all of the countries at once. So if I'm looking at, in this case of this bar chart, all of the average happiness scores across different regions of the world, I might decide I want to drill down into the specific regions. I might want to understand more about what specific numbers go into this average. This is related to a concept called semantic zoom, where what I can do is I can move down a level of detail. I can add more granularity to my data by zooming in. So for example, if I have this bar here for North America and I'm interested in the data for North America, I can click on the bar for North America, zoom in, and I can see the two countries that represent that average value. So this is that basic idea of semantic zoom, that I'm actually changing the level of detail, the level of granularity I'm looking at in my data. One trick with panning and zooming is that occasionally you might find yourself getting a little bit lost. For example, if I gave you this bar chart here, you couldn't necessarily tell me what region did this come from, or what other regions exist in my data set. And so this idea of zooming in and looking in detail and panning about to different elements of the display and then coming back out to a higher level of detail and having no idea what it was you were looking at is related to an idea called desert fog. And the basic idea with desert fog is that we are using zooming and panning to remove the context of the rest of the visualization. And once we interact with the data enough, the analyst just simply gets lost. They can't remember where they came from. You can kind of think of this, and the reason this comes from the idea of desert fog is you're roaming around in the desert during a sandstorm, you roam around, you lose your sense of direction, you lose your sense of context, but everywhere you look more or less looks the same. So there are two techniques that we have for allowing analysts to anchor themselves in that big picture of their data and avoid this idea of desert fog. The first of these is called overview plus detail, and the second is called focus plus context. And the basic idea behind both of these techniques is we're finding ways to update the visualization such that we get the big picture overview of what's going on in our data, while also drilling down into the details that matter to the current questions I'm trying to ask. So when we think about overview plus detail, the basic idea here is that we want to zoom into our specific subsets of the data and look at those subsets in detail. And we're going to do that through one visualization that in particular just really focuses in on what's going on in this one spot we're looking at. But to make sure we don't lose our place, we don't lose our sense of what it is we're looking at, where have we drilled down into, we can show where that detail is in our overview visualization. So for those of you who play video games, you can think of an overview visualization as our mini map, and our first person view is our detail. We are getting lots and lots of information about what's going on in a specific area of our data, but we're still retaining our situational awareness of what are we looking at in the context of everything else that's going on in our data set. The key thing when we're thinking about overview plus detail visualization is that we do have two separate visualizations that work together. For example, we can have this bar chart over here on the left, and as I click on different regions of my bar chart, the chart on the right updates with specific information about the countries represented by those bars. So this is an example of overview plus detail. I also have, again, this idea that complements overview plus detail is called focus plus context. So unlike overview plus detail, the basic idea with focus plus context is we're avoiding desert fog by keeping all of our data in a single view. So we focus in on an important region, we show that in greater detail, but we push the remainder of the data out to the periphery to retain the context of the data in that region. So for example, if I wanted to drill down into the data for North America in this bar chart, I might show the bars for North America here in more detail, maybe make them a different color so I know that I'm looking at a specific subset of the data, but I still retain the aggregated bars from all the other regions of the world on the outside. So this is an example of something related to a technique called table lens. So when we have table lens, what we have is we might have a big table of data, and we look at the overview, the big picture of all the rows of our table and kind of see a visualization showing everything that's going on. But we might actually show specific values only for a subset of rows in that table. For folks who are familiar with photography, another technique you'll see sometimes in visualization is an idea called fisheye lenses. So with fisheye lenses, you have the center of your cursor where you're zoomed in a lot of detail, and then you distort the regions right around that center to try to borrow space such that you're situating the view that you're looking at in the context of that big picture overview visualization. So that's all I want to cover for this first interaction module. Again, I highly encourage you to go over to the Altair notebook, explore the examples, get hands-on, implement and play with the examples you see there. In our next video, we'll cover the remaining 4 kinds of interactions, which are reconfiguring, filtering, encoding, and connecting our data. And these really have to do not with updating and looking at the current visualization, but really thinking about how can we use interaction to change the perspective we're looking at with our data, to change the kinds of charts, the kinds of encodings that we're using, and to understand and connect relationships across multiple charts. So I will see you all then.